X grams sodium carbonate reacts with 0,028 mole of hydrochloric acid at 25 degrees Celsius. The balanced equation for the reaction is that thing. 448 centimeters cubed of CO2 gas is produced during the reaction. The molar mass, the molar volume at 25 degrees Celsius is 24,47 decimeter cubed mole minus 1. Then the question is define the term limiting reagent. Reagents.
Okay, thank you so much, Sam.
Now you're welcome, sir.
I'm welcome, Sam. Yes, Sam. So here they say X grams of sodium carbonate reacts with 0.028 moles of hydrochloric acid at standard temperature, STP 25 degrees Celsius. The balanced equation for the reaction is given as follows. All right. Now here they say 448 cubic centimeters of carbon dioxide gas is produced during this reaction. Okay. The molar volume at 25 degrees Celsius is 24.47 cubic decimeters per mole. And this is a trick. That's why I'm constantly telling you, don't put that 22.4 cubic decimeters per mole into your head because now you're going to have real challenges. Yes, you know that it's at STP, but even here they tell you that it's at 25 degrees Celsius, which is standard temperature. So very, very important. It changes depending on the mood of the examiner. It's not a constant, all right? Okay. Then the first question says we need to define the term limiting reagent. You know what is the limiting reagent? And then they say name the law that states that 1 mole of any gas occupies the same volume at the same temperature and pressure. So, does anyone have any idea of which law is that? Hmm. Well, no one has an idea. That's actually Avogadro's law. So yes, sometimes they can ask you to state Avogadro's law in the exam. Please know how to state it. Then next they say, determine by calculation which substance is the limiting reagent. In other words, is it sodium carbonate or is it hydrogen chloride, hydrochloric acid? Now, if you remember well, in order for you to identify the limiting reagent, that's when they gave you information about both of your reactants that will enable you to calculate the number of moles of those two reactants. But in this case, the pattern has been changed. Do you see that? Why? Because they didn't give you any information about sodium carbonate that will enable you to find its moles. No, no, they didn't. Not at all. Because they just said X grams of sodium carbonate. And they also don't give you the concentration and the volume of sodium carbonate. Well, they can't anyway because it's in solid phase. So it means for this one, you are not going to do it the normal way of determining the limiting reagent. It needs a little bit of intelligence, thinking, that is to say. But then you are given the moles for hydrochloric acid. Okay. Now the question is, how can you determine which one is the limiting reagent if you don't know information about sodium carbonate? Well, they did give you a product. They gave you information about a product that can help you to find the number of moles. because they gave you the volume of carbon dioxide gas that is produced. They also gave you the molar gas volume. So what you're going to do here is to find the moles for carbon dioxide. After that, what are you going to do? That's a very good question. You're going to determine how many moles of hydrochloric acid were needed in order to produce this number of moles for carbon dioxide. Do you get what I'm saying to you? Because already for this hydrochloric acid, we are given the number of moles that are available at the start of the reaction. That's the 0.028. Now we need to know how much was actually used in order to produce this carbon dioxide gas. Right. I think I've made my point, so let's go and destroy it. Yes. Remember the most important lesson that I'm trying to teach you. Anything you can do moving forward, you must be able to reverse it. You know, one day my physical chemistry lecturer, she asked us a question in class. She said, what happens when the temperature of a substance, no, when the vapor pressure of a substance is equal to its atmospheric pressure? That's what she asked us. And the whole class was dead in silence. Why? It's because we are used to defining the boiling point. We are used to moving forward. What is the boiling point? The temperature at which the vapor pressure of a substance equals its atmospheric pressure. But now this lecturer was very intelligent. She said, what happens when the vapor pressure of a substance equals its atmospheric pressure? She wanted us to move backwards. So from that day, I've been preaching to every student that I teach that anything you can do moving forward, you must be able to reverse it. That's a very important lesson. And I'm ashamed to say I didn't know what happens. Eish. Yeah, it's bad. But I'm glad you've learned this lesson. It's always wise to learn from other people's lessons. Nevertheless, let's go back to science. Well, it was actually a lesson about science anyway, which I learned in a science class. So I wasn't really, what, deviating, right? Okay. So we said the first thing we need to do is to calculate the number of moles for carbon dioxide gas. But then we know that in order for us to find the moles, this is the formula we are going to use. Now, the volume that they gave us is in cubic centimeters, and we know that that is a red flag. We have to divide this by 1,000, in which case we get 0.448. All right. And when we divide this 0.448 by the molar gas volume, which is given to us as 24.47, well, if we press everything into the calculator, we simply get 0.018, 30, and so forth. Well, I'm not going to write all of them, but it's very wise to actually write all of them so that the answer that you get doesn't really differ to the answer in the memo. But then you don't really need to stress that much about this because there's always a range of answers in the memo. They'll say anything in this range, then you can mark it. But to be safe, maybe try to write 6 decimal places. Yeah, I think it's much better to do it like that. So let's do it like that. So after 3, we have 0 and we have 8, 2, 4, 6. Not bad. It won't differ that much to the actual answer. Now that we know the number of moles of carbon dioxide gas that were produced, we want to know how many moles of hydrochloric acid were used in order to produce this much. Because we only have information about hydrochloric acid. That's the logic. So, well, the ratio here is actually 2:1. Now we want to know if we have 0.018308, then how much do we have of this? Well, the only reason I'm writing X is due to space, but actually, you're just going to say this one divided by this, multiplied by that. So I'll just write X here, that's fine. Although I don't really like writing X. So then, if you go to your calculator and say 0.018308 times 2, well, we find that the number of moles of hydrochloric acid that were needed will simply be 0.036616 moles. Okay, but then if you remember well, in the statement they gave us the available number of moles. Now we know the number of moles that are needed. So now we have to compare these two number of moles. We say, well, the number of moles of hydrochloric acid that are available at the start of the reaction, well, they're actually less than the number of moles that are needed. Because in the statement, they gave us 0.028, and that 2 is less than the 3 that we have there. Then the conclusion is hydrochloric acid is the limiting reagent. Right. So, any question on this one? You can go ahead and ask me a question. It was not usual, honestly speaking. I'm sorry, sir. You may go ahead.
Uh,
Oh, yes. Sorry,
so,
Elsie, it was you.
that's fine. So, sir, the steps of solving this never change because all I'm seeing is that the steps are similar. It's you first find the mole, then the ratio, then the comparing. Then if needed, we find the excess reagent.
Please repeat the last statement. I couldn't catch that.
So the first step is we find the moles. Second step, the ratio. Then third step is comparing. If needed, do we also do the finding the x's after after comparing and finding the limiting reagent if you want.
Do we also find the excess reagent? Is that what you're saying?
Yes. Is it
No, no.
necessary?
No, we don't. No, unless if they explicitly say, if they say straight or find maybe the mass in excess or what. But if they don't, no, we don't.
Okay, thank you.
Yes, if we just identify the limiting reagent, no, it's perfectly fine. Then the last question says, calculate the value of X. So, well, we know that X is actually the mass of sodium carbonate that reacted with hydrochloric acid. Okay. Now the question is, how do we calculate the mass of this sodium carbonate? That's a very good question. Well, remember the most important thing. What is that? Well, this X grams is actually the initial mass. So it means we just find it from the available number of moles for sodium carbonate. So the big question is, how do we calculate this mass, knowing that sodium carbonate is the excess reagent? And the question is not saying we need to calculate the mass in excess. No. We just need to calculate the original mass, the mass that was put into the reaction mixture. And one thing we know about the limiting reagent, which is hydrochloric acid, it's the one that we use in order to produce the quantity of a product. But here we are still going to use the same number of moles of carbon dioxide gas, which is the product, in order to find the mass of sodium carbonate. Yes, that is what we are going to do. That is what we are going to do. But let me think about it. Am I telling you the truth? I want to show you something because understanding this is really important. Now, this 0.033, in fact, 36616 moles that you see here, those are the number of moles of hydrochloric acid that we need in order to produce 0.0183 moles of carbon dioxide. But we realize that we are only given 0.028 of hydrochloric acid. This is what we have, but this is what we need. So what we have is actually less than what we need. What does it mean in simple language? Yes, I know that it means this is the limiting reagent, but what it actually means is this number of moles can never be produced. That's what it means. Do you get what I'm saying to you? In order for us to produce these moles, we need these moles for hydrochloric acid. But since we have less than what we need, it means these moles can never be produced. So then what does it mean? It means in order for us to calculate the number of moles, or maybe the mass of sodium carbonate, we can't use these moles for carbon dioxide because we can't produce that much due to the limitation of hydrochloric acid. We also can't use this. So what we need to do here is to use what we have. Yes, I think I've made a point. So it means we are still going to calculate the number of moles. Oh no, it's given to us already, sorry. For hydrochloric acid, those that we have, the available ones, and we are going to relate them to sodium carbonate, right? And what is the relationship, or rather the ratio? Well, the ratio is 1:2. Now, for this hydrochloric acid, we know that we are given 0.028. Now we just need to find the moles for sodium carbonate. We are using these moles, not the ones for carbon dioxide that have been produced. No way, because that amount is actually not produced. It was just helping us to determine the limiting reagent, but it's not really produced. So if we go to our nice calculators and say 0.028 divided by 2 times 1, we find that the number of moles of sodium carbonate will actually be 0.014 moles. And now that we know the moles, it's considerably easy to find the mass. Yeah. So we have 0.014 here, which is set equal to the mass. And this entire thing is divided by the molar mass. So we have 2 times the molar mass of sodium, 1 molar mass of 1 atom of carbon, and 3 for oxygenium. That's the Latin name for oxygen. And then we cross multiply here. So when you say 0.01 times the entire denominator, which is 2 into 23 plus 12. And if you're doing it like this, please remember to be careful when you press this into your calculator, because mistakes are at your fingertips. So yes, this is the mass of sodium carbonate that we actually had. Well, you could have decided to put an X here. Mass for X, mass for X. Yes, but if you used your M and not X, it's still necessary for you to conclude and say, therefore, X equals that much. Because the question is looking for X. So, yes.